Okay, we're starting chapter 3. Chapter 3 talk more about derivatives, so techniques of differentiation. So first we're going to talk about the product rule and quotient rule, then the chain rule. The chain rule I mentioned earlier a little bit, but we're going to go in depth of chain rule. So product rule, quotient rule, but I'm going to focus on the product rule because once you know the product rule, you don't really need to remember the formula of quotient rule. Okay, so let's see product rule. Product rule starts with a product of two functions. Let's see here. Right. So I have one function multiplied by another function. Let's give an example. Let's see if I have h of x written as x minus 2 cubed, then times x plus 3 raised by 5. So I can treat this one as f of x. I can treat this one as g of x. So when I take a derivative, so what I do, it's a sum. First, it's a sum of two things. The derivative is a sum of two things. The first term is taking derivative of the first one or the second one doesn't really matter because the sum is commutative. Because personally, I usually go this way. Take a derivative of the first one, multiply by the second one. Then take derivative of the second one, multiply by the first one. So taking derivatives of those two functions alternatively. So let's see this question, this one. If I want to find h prime of x, right? I just follow this formula. So I take a derivative of f, then I multiply by g, then plus I take a derivative of g and multiply by f. So let's find out derivative of f. But this is a power rule, right? Because something raised by 3, we're going to use power rule. So 3 times x minus 2 squared. Now, if I go inside, the derivative is 1, right? Derivative of x is 1. Derivative of negative 2 is 0. Then let's find the g prime of x. Similarly, that's 5 times x plus 3 raised by 4. And similarly, inside the derivative is also 1, right? But that by default, that's 1x. So derivative of x is just 1. Derivative of 3 is 0. Remember, derivative means the rate of change, right? The rate of change of x is 1. The rate of change of 3 is 0 because 3 is constant, will never change. So then we go back to the formula. So f prime 3 times x minus 2 squared multiplied by g, x plus 3 raised by 5. Then plus, because in the formula that's addition, plus f, this first function, x minus 2 raised by 3 times g prime, right? 5, I can write it up front, 5 times x plus 3 raised by 4. And that's it. So that's product rule. Let's see some examples. So here I have f as x squared, g as x cubed. Right, the product of those two, which means, let's call it h of x. Just x squared times x raised by 3. Of course, you are thinking, why do I use a product rule? Right? This is easy. I just combine those two to get x raised by 5. Then the derivative is just 5x raised by 4. And of course, we can do product rule also, right? By separating them. So by taking derivatives alternatively, so I take derivative of the first one, derivative of x squared, which is 2x, multiplied by the first one. Then I take derivative of the second one, x cubed, which is 3x squared, then I multiply by the first one. Then I simplify it, right? So the same answer, but there's no reason questions like this, we use product rule. Right? We would do the algebra first, then take derivative. Well, let's see this one. This one we can FOIL it, or we can use product rule. Well, let's try to use product rule, right? Let's take a derivative of this one, which is 6x squared minus 5. Well, let's take derivative of this one. Well, that's just 3, right? Then we just write derivative of the first one, 6x squared minus 5, times the second one, plus derivative of the second one, 3 times the first one. And that's it. Of course, if we can simplify. Okay. Simplify, we should get this answer in the end. Or this thing, if a function is squared, g of x squared, right? This is gx times gx. Or we can treat this one as g of x squared, right? So that should be, the derivative should be y prime equals to 2, right? Exponent 2 of g of x raised by 1, then multiply by derivative inside, which is g prime of x. Or we could use the product rule, right? We'll also reach the same solution. Let's see this one. So the y prime should be derivative of the first one, which is 4 times x squared minus 1 raised by 3. Then multiply by the derivative inside, which is 2x. Multiply, then 2x, that's the derivative of the first one. Then multiply by x squared plus 1 raised by 5, the second one. Then add, product rule, always add. Add the first one, x squared minus 1 raised by 4, times the derivative of the second one, which is 5 x squared plus 1 raised by 4 times 2x. Then we can simplify a little bit. Right? 4 times 2x, 8x. X squared minus 1 raised by 3. X squared plus 1 raised by 5. Plus 5 times 2x, 10x. X squared minus 1 raised by 4. X squared plus 1 raised by 4. We can leave like this. We can leave like this. Okay, quotient rule. Quotient rule, usually I don't emphasize on quotient rule. Let's see. Quotient rule means I have one function divided by another function, right? But of course, I can rewrite this one as f of x times g of x raised by -1. Then I use product rule, right? I take derivative of the first one, which is f prime of x, multiply by the second one, which is divided by g of x. Then this should be minus, you will see why, because when we take derivative of this, it will be -1. So plus -1 will be minus, right? Minus -1 of g of x, then raised by, right? I'm dealing with this exponents. So -1 I pull up front, then g of x raised by -1 minus 1, which is -2. Then multiply by g prime of x. So let's rewrite this. So we have f of prime of x divided by g of x then minus g prime of x divided by g of x squared, right? And of course, we can multiply g of x here. Then this bottom becomes square. Then now, oh, I forgot something. I have to multiply by the first function, right? I have to multiply by the first function because I take derivative alternatively. This is a derivative of g raised by -1. But then I have to multiply by the first function. So the numerator is f prime of x times g of x, then minus g prime of x times f of x, then divided by g of x squared. So which is the quotient formula. Okay, so either one works. If you want to, right, remember like the quotient rule, that's this. If you don't want to bother with it, you can go with the product rule. Let's see some examples. Let's see this one. So the top function, f function, is x, identity function. The bottom function is a linear function, right? If I want to go with the product rule, I can write as x times 2x plus 3 raised by -1. Then I take derivative of the first one, which is just 1, then multiply by the second one, so I get 1 over 2x plus 3. Then I take derivative of the second one, multiply by the first one. First, let's write down x. So when I take a derivative of this one, I get -1. Then this such raised by -2, because -1, -1, -2. So I put down in the denominator square, right? Then I have to take derivative inside, which is as 2. So I get this. Right? So if I want to use the quotient rule should be this one, then multiply by 2x plus 3. Then in the end, we should get 3 over 2x plus 3 squared. So quotient rule saying take a derivative of the top, multiply by the second. Subtract, take a derivative of the bottom, multiply by the top. Okay. Then divide by the bottom square. So either one works. Let's see more example. Let's see this one. So I could use product rule. I have x cubed times x squared plus 1 raised by -4. So I'm just taking derivative. So this one derivative is 3x squared. This one derivative should be -4. 4 goes to the numerator, then times 2x, because the inside will give us 2x as derivative. Then divided by x squared minus 4 raised by 5, because -4 minus 1 will be 5. Then I can put together as first one, the top derivative of the top divided by the bottom minus 4 times 2x, 8x divided by x squared minus 4 raised by 5. Or I can go with quotient rule. Right? Quotient rule is saying take a derivative of the top, multiply by the bottom, then subtract, take a derivative of the bottom, multiply by the top, then divide by the bottom square. So that's why we have 4 times 2, get 8, x squared plus 1 raised by 8. Then we simplify a little bit, the two answers should be exactly the same. You know, most stuff is algebra. If you have difficulty with algebra, that will cause problem. The idea of differentiation is very simple and very direct. Let's see this one. This one requires us to simplify after we take a derivative. So this one, okay, so this one is saying after the quotient rule. So let's apply quotient rule. So y prime equals to derivative of the top, which is 1, multiplied by the bottom, which is x plus 1, cube, right? Because it's 1 multiplied by something, I don't really need to write down this 1. One in multiplication, we can ignore it. Right? Then so this is derivative of the top 1 multiplied by the bottom. So that's this one. Then minus the top multiplied by the derivative of the bottom. What's the derivative of the bottom? Derivative of x is 1. Derivative of the second term is 3 times x plus 1 squared. And derivative of inside is 1. So 1 plus 3 times x plus 1 squared. Then divided by the bottom square, which is x plus 1 raised by 3, then squared. We would never want to simplify the denominator, okay? The numerator can simplify. The numerator will get x plus 1 raised by 3 minus x, right? Because minus x times 1 minus x, then minus 3x x plus 1 squared. Or denominator, I'm going to skip writing it. So x minus x becomes 0. Okay, so I have x plus 1 raised by 3 minus 3x times x plus 1 squared. Same denominator. Right. Then I see x plus 1 squared is a common factor of the two terms in the numerator. So I factor out x plus 1 squared. I still have x plus 1 left from the first term, the minus 3x. So the denominator is the same, right? Then I simplify this, I get x plus 1 squared times x minus 3x is minus 2x. So I write as 1 minus 2x divided by x plus 1 raised by 3 squared. That's it. That's a simplified version. Okay, let's see this one. So this asks us to use multiple differentiation rule. Okay, let's see. So first, we're going to rewrite this function as such. We're going to write it as x squared plus 7 divided by x plus 1 raised by half. Then the bottom one, we're going to write it as negative. So we're going to split, writing as x squared plus 7 raised by half. Then multiply by x plus 1 raised by negative half. So as you can see, I'm going to use product rule. Product rule, so f prime equals to take derivative of the first one. Let's use a different color. Let's just take derivative on the side. So I got a half times x squared plus 7 raised by half minus 1, which is a negative half. Then I have derivative from inside multiplied by 2x. Well, half times 2 becomes 1. So this term becomes x in the numerator, but this in the denominator. So square root of x squared plus 7. Right? So this will be the derivative of the first term. Derivative of the second term, I have negative half, right, of x plus 1 raised by negative half minus 1, negative 1.5, or negative 3/2. Right? Let's write negative 1.5. Then derivative inside just 1, multiplied by 1. I don't really have to write it. So let's rewrite this. So that's negative 1 over negative 1 over 2 times x plus 1, because this 1 is just x plus 1 itself, right? The half is the square root of x plus 1. So the derivative is this. So what did I do? I pull this negative half up front and minus 1 from negative half to get negative 1.5. Negative 1.5 is negative 1 minus half. Then derivative inside just 1. So I rewrite. So I get -1 over, because these 2 in the denominator, and everything from x plus 1 is in the denominator. X plus 1 raised by -1 goes to the denominator as x plus 1. X plus 1 raised by -1/2 goes to the denominator as the square root of x plus 1. All right, now we can write the derivative. So I'm taking derivative of the first one, which I get x divided by square root of x squared plus 7. Then multiply by the second one. But what is the second one? The second one is the square root of x plus 1, right? Because it's x plus 1 raised by -1/2. Then plus, well, plus, since this one is a negative, so I know I need to change to be plus or negative, change to be negative. Then the first one, which is square root, which is the square root of x squared plus 7, which is this one, square root of x squared plus 7. That's the top one. I shouldn't say first one. Or if in this case, I should say first one. But or you can think as top one, because I read it as product, right? I could say first one. Then multiply by the derivative of this term. So that is 2 times x plus 1 square root of x plus 1. And that's it. All right, so that's to use product rule. The example, let's see the example. The solution from the text. So, right. So the first, they use the chain rule. They said, okay, I'm going to deal with this one first. So I take half down, then I do half minus 1. I get -1/2. Then I need to take derivative inside. Right? Derivative inside is a quotient. So I could use the quotient rule. So I have the first term, then I take derivative of the inside. I use the quotient rule. Right? I do the top, derivative of the top times the bottom, minus derivative of the bottom times the top, then divided by the bottom square. Then simplify a little bit. All right, so either method works. So you pick one to follow. I like the product. I like to rewrite as a product, so I don't have to bother with quotient. Okay, let's see in this applications. Suppose the total cost of manufacturing X units of a certain product is given by this cost function. Then the average cost per unit is defined as such. So I have C of X divided by the quantity, which is called average cost per unit, right? Because this is C of X is the total cost. Total cost divided by how many units being produced. So that's the average cost. So we call the marginal cost. Remember, the marginal cost is the derivative of the cost function. So they want us to show at the level of production where the average cost is at a minimum, the average cost equals to the marginal cost. Okay, so basically this is a proving question. I'm going to skip this. All right, basically we just use the quotient rule. Or we can rewrite this x as x raised by -1 to do the calculation. Right? Then we'll see the two are the same. All right, so that is chapter 3, section 1, talking about product rule and quotient rule. The next one, we're going to talk about chain rule. Chain rule we have used already, we have mentioned already. But now we're going to see more examples. Okay, chain rule is to deal with compositional functions. Right, so this is called composition functions. So let's understand this notation. I have two functions, f of x, g of x. Right? I could talk about f composed with g or g composed with f. But for us, okay, remember function just means I have this input, right? However, this function is defined is in terms of this x, the input. So if I write like this, that just means the function f, the input is g of x. For every x appeared, I just change to g of x. I'll give an example. Let's see f of x defined as 2x squared. G of x defined as x minus 1. I just give an example. So what is f of g of x? So that means f takes the g as input. What's g? G is x minus 1. Now, instead of this x, everywhere x appears becomes x minus 1. So the function is a 2x squared, 2 times the input squared. So input is x minus 1 now, 2 times the input squared. That's it. That's f composed with g. What's g composed with f? That means g takes f as input. F is a 2x squared. How is g defined? G is saying the input subtract 1. The input subtract 1. And that's it. All right. Okay, let's see this example. F is defined as this. G is defined as this. So let's find f of g. So f of g, so which means I'd like you to write one more step, okay? F of g, what is g? G is x cubed. Write down one more step, right? Then, or you can write this way too, right? Because f is defined, f of x, now the input is g of x, every x change to be g of x. You can think this way also. Now, what's g of x? You substitute g of x as x cubed, right? Well, what if we want to find g of f of x? That means g takes f of x as input, right? So now g is x cubed, just input cube, f of x raised by 3. And that's it. Decomposing compound function. Okay, let's see these examples. So for the first one, I can define this, right? I define f of x as x raised by 8, right? If you give me an input, I'm going to raise the input by 8 degrees. And g of x is just a base. X raised by 5 plus 9x plus 3. Then h of x just f composed with g. Just f composed with g, right? F takes a g, this as input, then raise the input by 8. Let's see B. I can define f of x as a square root of x, right? If you give me an input, I'm going to put a square root. I'm going to square root the input. And a g of x I can define as 4x squared plus 1. Then I can define k of x as f of g of x. Right? You give me 4x squared plus 1 as input, then I square root that. Okay, chain rule. Chain rule is saying if we have a function raised by r, we pull this r down, right, to the base. Then we keep the g of x, we subtract 1 from the exponent, from the r. Then we multiply by the derivative of g, the inside. Let's see if I have this. I have 3x squared minus 1 raised by 4. I want to take derivative of this, right? So I pull 4 down, I rewrite whatever inside the parentheses is. I subtract 1 from 4. Now I multiply the derivative inside. The inside which is 6x. Okay, that's what this formula is for. This formula actually haven't seen already previous chapters. Now, composition function, f composed with g. Now remember, g is the input of f. So we take derivative of f first, which will have f prime. However, its input still g of x. Right? Then we multiply by the derivative of g. So let's see the function we have seen before. Like remember this one. Right? The h function is x raised by 5 plus 9x plus 3 raised by 8. So what's the h prime? We take derivative of 8. That's like outside f. This is a down, x raised by 5 plus 9x plus 3 raised by 7. Then multiply by the derivative inside, 5x raised by 4 plus 9. That's it. Okay, this is saying your function is not defined specifically. We just follow the rules, write down the notation. All right, this is not important for us. Another kind of notation is this. This is saying dy dx. We want to find the rate of change in terms of y and the x. We may go through some middle variable, u, right? Which means y can be defined in terms of u. Let's see 3u squared. And x is defined in terms of u, or maybe 2u minus 1, stuff like that. So there's a middle variable. Then we can find the rate of change of dy in terms of dx going through this, which means, so y prime of u equals to 6u, x prime of u equals to 2, right? Or you think dy du, just y prime of u. Okay, it's a similar notation. That just equals to 6u times 2, which is 12u. Okay. Okay, let's see this one. So we want to find the rate of change of y in terms of x, right? Not in terms of u. But we see y is a function of u is a function of u. So all we need is find y prime of u, which will get 5u raised by 4 minus 6u squared. And then x, oh, hold on. This u is defined as x squared plus 1. Okay. So we need to do, let me erase this. In this case, we need to find a u prime of x, right? Which is a 2x. You could think of this like u prime, or this is du dx, right? So notation-wise, du dx. And this is dy du. Now, what is y dy dx? That equals dy du times du dx, right? You see these two, one in the numerator, one in the denominator. So dy du is 5u raised by 4 minus 6u squared. Then divided by du dx, which is 2x. Hold on a second, I think that's, right, dy du equals this. Let's see what they want to do. Du dx is 2x. Oh, okay, because we know x, right? Because we know x, okay. So here. Yeah, it looks like a weird axis here, but yeah, it is a weird 2x. But then we have to solve for x. But then we get two values, right? Because we have a u equals to x squared plus 1. And we solve for x squared. We get x squared equals u minus 1. Then x equals plus minus square root of u minus 1. Oh, okay. This is just saying, because we know u, let's change u back. Du dx, right? Because we want the variable to be x, not u anymore. Yes. Because this one, we want to, this dy dx, right? This is in terms of x, no more u. So what do? We just substitute this u into this. So we got 5 times x squared plus 1 raised by 4 minus 6 times x squared plus 1 raised by 2 divided by 2x. All right. So this is saying I have y defined as a function of u. Right? Think about y goes to u. Now u goes to x. So I want to skip u. Just find a relationship between y and x. So no more u. Right? I don't want no more u. So the derivative, the rate of change of these two, just this. I want to find the rate of change of y in terms of x, skipping u. So everything is represented with x. So we use this formula. Dy over dx equals dy over du, right, which is just y prime, get it from here. Multiply by du dx, which is just get it from here, u prime. Okay, let's see this example. The demand equation for certain blunt graphing calculator is this. So P is a function of X, linear function, where P is the price of one calculator in dollars, and X is the number of calculators produced and sold. Determine the time or rate of change of the total revenue if the company increases production by 200 calculators per day, when the production level is at 6,000 calculators. All right, I'm going to just follow the textbook solution. So we know from previous chapter, the revenue function equals the price multiplied by the quantity being produced or sold, right? And the price given as 86 minus 0.02x. So simplify this, we just get negative 0.02x squared plus 86x. Downward parabola, right? Downward parabola, revenue. So this is revenue function, downward parabola. We are told that when x equals 6,000, the production will increase the rate of 200 calculators per day. So what does that mean? Remember, it's the rate of change. So which means dx over dt, right? Per day, time is involved. Time is involved, right? Time is involved. So when x equals 6,000, the production will increase the rate of 200 calculators per day. So dx dt equals 200. That's how fast is it changing? So when x equals 6,000. So we are asked to find the rate of change in terms of the revenue, dr dt. Dr dt. So by the dy dx equals dy du times du dx. So get something similar. So dr, so the rate of change of the revenue or marginal revenue divided by dt equals to dr over dx, because we have this function. Right? We can find r prime. So this is r prime of x. Then multiply by x prime of t. You see dx, 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 one in the numerator, one in the denominator, right? Of course, equals dr dt. So we just have to find the derivative of R, which is dr dx. What is R prime of x? They equal 2 times 0.02 with negative 0.04 x plus 86. Then x prime, right? X prime of t were given 200 constant rate of change. So just multiply those two. So this is a dr dx. Then dx dt is 6,000. Not 6,000. dx dt is 200. Just multiply this. So this equals to negative 0.04x plus 86 multiplied by 200. A linear function, right? And also the slope is negative. As you can see, the price decreases, the quantity increases. So just multiply these two. Then at 6,000, when the quantity is 6,000, we just plug in 6,000. So we'll get this much, 12,400 per day. So this is a typical application question, how we use this in life. All right. So in this case, we're given revenue function, or given actually price function with form revenue, because revenue equals the quantity multiplied by the price. Now here we get a quadratic formula, quadratic function, or polynomial degree 2. And also we're given the production, the rate of changing of the production. It increases 200 when x equals 6,000. So we want to evaluate. So we want to find the rate of change of the total revenue, dr dt. Right? When what happens? When the increased production is 200 and at the level 6,000 calculators. So that's why we need to find the dr dx, which equals the dr dx. We need to find dr dt. That's dr dx times dx dt, which is this is dr dt. This is a dx dt. Multiply these two. Then we plug in 6,000. The quantity is given as 60,000. Okay, so yeah, so these two sections talk about product rule, quotient rule, and chain rule. All right, so let me stop here.